This is how we are going to use list as well as a function. Now coming to the next example. The next example is something like this. If I have a list and I am passing the list to a function, the function should return for me the square of each of the elements of the list. The function should return to me the square of each of the elements in the list. Let's say this is list 1 and I should call, let me say I should call square of list 1. I should call square of list 1. It should return for me another list which should be like SQ, S square of each of the elements of list, SQ list. And I should print the original list. I should say the original list is comma lst1, and I should say the square of each of the elements in the original list is comma SQ list, right? And I need to now define the square of list in a different way. So this is my, and I need to find out the square of list, which means I need to return only one list. Okay, let me say it's going to be SQ. It's another list, SQ. How do I form SQ? So can I do something like this? Some of you may be thinking, okay, maybe I can do it like this. For every element in list. Okay, so first of all, you will say for every element in list, but how do I access? Okay, I need to store it in a corresponding element in SQ. No, so that's not possible. Which means for every element, I cannot say first of all for every element in list, I need the index. For every index in range 0 comma list of, or can I say in range len of list, can I say that? Len of list, right? Len of list is gonna be, if it's going to go till there, okay, I can, for now I'll just, I can say list of I, right? If I say list of I, it's going to print each of them. So for now, if you want, I'll just print that out just to show you what happens. Of course, that's not going to return, you don't return anything. Okay, I'm just going to put that there. So what happens? The square of the elements, okay, it's none because that's not yet defined. Okay, and 1, 2, 3, 12, 13, 14, 13, 4, 19, 5, 6, 15. Okay, it just prints for me each of the elements in the list when I do a list of I. Now I need to create a new list. Okay, some of you may be thinking, I can just do something like this. I can make another list, or I can say I need to make another list, right? So if I say something like this, if I create a list 1 which is going to be equal to list, and then I say for every element list 1 of I should be equal to list of I the whole square, and then so I'm creating a square of list. Let me say this is SQ, and this is SQ of I. Each of the elements in SQ of I is going to be list of I the whole squared, and I return SQ. Now, if I do F5, the original list is 149,144,169. It's returning. The original list has also changed, and the square has also changed. No, I don't want both of them to change. Why did both of them change? Because I had made the square as equal to list. If you remember my concept at the start of this particular lecture, which means one of the ways that I can do it is I can do something like this. Instead of directly saying equal to, I can just say list.copy. If I do a list.copy, right, and if I do F5, okay, the original list is not going to change, but my squares are going to be returned. This is one of the ways. Second way, I can define an empty list, that is SQ, because that is the right way to say it. SQ is nothing currently, but SQ can be SQ for every I in range this thing. I can just do SQ dot append. I can keep appending a value which is list of I the whole square. And if I'm using this particular method, I don't even need to say list of I the whole squared. Over here, I don't need to use the range function. For every element in list, I can just say append element square, right? And if I return SQ, save it, F5, original list is this, square of each of the elements in the original list is. Hope you understood these examples of list. With this, we are done with a few examples of lists which are essential for understanding lists to be used in IoT. Hope you are with me up till now here as we go on to another example or to another topic, to another data structure for now. Thank you.